Okay, so it's amazing to have you guys once again. We are glad to have you join us, guys. For so many persons, cloud computing is a new concept. How beautiful, how amazing it is for you to sit at the comfort of your home and work for companies, right? Everyone now is at the comfort of their homes. All right. So how amazing that is. So for the past few days, we've had 3 sessions already, drilling you through some basic concepts in cloud computing. And so today we're going to continue, right? We've had 2 sessions already. Today's the third session. And today is going to be around content delivery. I'm sure many of you must have been asking yourselves, what is this content delivery all about? Right? So we have an amazing engineer who is going to drill you guys through the session of today. So that's no other than Prof. Sensini. If you can hear me, Prof, can you hear me?
Yes, 505.
Okay, great, great. So guys, for the next 1 hour to 1 hour 30 minutes, you're going to be with Prof. Sensini. I want you guys to be focused as you've been from the onset. I want you guys to write down your questions. I want you guys to jot down those things that make sense to you. At the end of the day, you're going to now drop in the chat, right, in the group as well, on one thing that you've learned, right? He's going to drill you guys through an amazing session. So over to you, sir. You have the mic.
Okay. 1 second. Okay. Sure. All right. Can you guys hear me?
Yes, Prof, we can hear you.
Okay. So once again, thank you all for making it tonight. We're going to be focusing on content delivery at a very high level. So to the audience and everyone, welcome to today's workshop on content delivery. My name is Peleke Sensini. I'm a cloud architect and DevOps engineer. I'm one of the tutors at Solavise Tech. I look forward to having an amazing time with you. So I'll go straight ahead and share my screen and we could begin. All right. Great. Fine. So we're all fascinated and excited by the amazing technologies we encounter on a daily basis. And it's very easy to think that these are some sophisticated tech, or we cannot implement it. Or you might think, I'm too young for this, or I'm too old for this. Well, I'm not from an IT background. There are so many things that may try to turn you off. But one thing I can tell you guys today is that that's entirely not true. And I'll start by sharing a personal story, right? So throughout my cloud journey, when I was especially when I was preparing for my certification, while I was studying, it will shock you to know that towards the end of my preparation, the person who actually prepared me, who gave me the last finishing touches before I went in for the exam, was a 45 years old woman. She's old enough for me to be her grandson. She's 45. She's a Cameroonian and she's in tech. So this prof you're seeing here, this person that's going to walk you through today, received aid from a 45 years old woman for certification in IT, a professional certification. Do not think you're too old to be here or young. So another thing is, when I was studying, I remember in my class, not only being one of the youngest, I would say, but one thing that I picked out from the people I studied with throughout my career was that those who made it to the end were aged 30 to 35 years and above. I mean, most of my mates quit. They quit halfway. I mean, I'm talking about the ones with the young brains, the ones that are vibrant and intelligent, they quit halfway. Most of those who made it to the end are the old ones. That's to tell you that you don't have to be a genius. What you actually require in this field is fundamental to soft skills. You would think, why were they the older ones that made it to the end? Because they are more resilient. They understand that it's a step-by-step process and it's a day, but they were able to make it to the end even more than the younger ones. So this is a special message I had for those of you who think that this is not your time, or your time has passed for things like this. Actually, today, as we're dealing with content delivery, I actually had plans for a guest with us tonight, and it's the woman whom I prepared with. And unfortunately, when I reached out to her, she was sick. She fell sick yesterday, and she told me she would not be able to make it. I would have really loved for her to be here to share that personal experience with you guys, and actually let you know that you can do this. And one other fascinating thing, despite being 45 years old and something like that, she's more of a DevOps person. She's more into code and stuff like that. You would think that if you're old, you'll not be able to understand code, but that's who she is. So I just wanted to share that with us. I really hope that she was able to make it for us. So we're going to go straight in. Now, when we talk around content delivery, many of us on our daily basis, you would bear with me that you've come across situations where you visit a website. Let me take, for example, you visit a website in Cameroon, and it's English. It's your favorite shopping website. You always shop from it. It's English. And let's say you go on a trip to France and you want to visit your favorite shopping website. It's in French. You're like, how is this possible? This is my website I use on a day-to-day basis, and it's normally English. Why is it French? Is it because I'm in France? How does it know I'm in France? To be able to understand that I'm a French-speaking person, for it to display me the French version, you would look at BBC. There's a French version. Those in China, everywhere. How do they do that? That curiosity, maybe you've been triggered at some point to find out, but you've never really known where to begin or how to go about it. Another scenario is where a family friend of yours in the United States tells you, hey, there's this cool website I always get stuff from. Maybe you might want to look at it to shop. And you try to access the website, it's blocked. You go back and you're like, hey, that website, I cannot access it. It seems to be down. What's happening? And your family member or your friend tells you, no, it's cool, I'm using it. So how is it possible that these companies can be able to grant access to their content to some people and block others? How is it that they can be able to deliver different type of versions of content to different people based on their locations or based on other policies? When I tell you what, the answers are all here. And you might think that the guys behind doing this thing are some geniuses. Oh, well, they are, because you will become one in due time, but it's not that as complex as you would think. Now, we as humans, we are not good with numbers. We are not good with digits. I tell you what, we are so not good. We are good with names. And so that's how different and opposite we are to computers. Computers understand binary language. They understand digits. That's what they understand. So DNS, that's our first topic on content delivery, the domain name system. This is the system that translates human-friendly host names into machine IP addresses. So what am I saying? Every website or every digital stuff you've accessed on the internet is represented by an IP address. You go to your website, your browser, and that's actually an IP address you're talking to. As a matter of fact, looking at my screen, you can see a typical example. How many of you before today knew that google.com is an IP address. Type in the IP address you see on your screen on your browser right now, and it'll take you to google.com. If you go on your browser and you put 172.217.18.36, it will route you to google.com. And just like this is how so many examples, let's say 172.217.18. Let me just try that. So that's what I'm saying in effect. I did not type google.com. I didn't. I just simply put an IP address, and that's the IP address for google.com. So every website you see out there is actually an IP address. There's an IP address behind it. And this is so because imagine that you had to be able to remember google.com by 172.217.18.36. Imagine that that's how you were bound to remember websites. How many websites will you be able to remember in your life? I bet that most of the people on this call they even have difficulties remembering their own phone numbers. Then imagine you having to keep digits or numbers like these because you want to be able to remember websites. Before we continue, just give me a minute, guys. Okay, so that's what I was saying. It's so difficult. It's going to be very, very difficult for all of us. Now, how does DNS work? How does DNS work? Don't bother so much about what you see on your screen. It may sound strange for now, but just listen to what I'm saying. What I'm saying is a very simple explanation of what you find on your screen. And we're going to be going detail into stuff like this during the training. So how DNS works is there's a computer somewhere sitting on the internet. There's a computer, right? So I want to just use those terms. There's a computer sitting somewhere in the internet that when you go in your browser and you type solavisetech.com, your browser sends that example or that website, solavisetech.com, it sends it to that central computer in the internet. And it asks that central computer, do you know solavisetech.com? If you see where my mouse is, your browser from here asks this central computer, do you know what Solavise is? The central computer is going to say, hey, I don't know what solavisetech.com is, but I think I know what .com is. So it's going to take this request here and send it here. Say, hey, do you know what solavisetech.com is? So actually, when this central computer receives the domain you've typed in your browser, that's solavisetech.com, when this central computer receives it, it takes it and it sends to this first guy here that, hey, do you know what solavisetech.com is? This guy is going to say, hey, I don't know what solavisetech.com is. All I know is where you can find .com, right? It's where you can find .com. So this guy now is going to send it back to this guy, and this guy is going to say, hey, I contacted someone before. I was looking for solavisetech.com. I contacted someone before, and the person told me that he does not know where solavisetech.com is, but that you are .com, and maybe you would be able to help me with solavisetech.com. This guy is going to say, hey, yeah, I am .com, and I don't know what solavisetech.com is, but I think I know where you can find it. And this guy is going to send it back to him. And the central computer is going to go again to the third person and say, hey, I've contacted two people before. I'm looking for solavisetech.com. I succeeded to get .com, but the last person told me that I'll be able to find solavisetech.com to you. And this last guy now is going to look within his system and say, hey, yeah, I know what solavisetech.com is. I have the server, I have the IP address of solavisetech.com. And this guy now is going to send it to this central computer, and this central computer is going to send it back to your browser. Then your browser displays solavisetech.com. So you would imagine that all of this process happens within seconds, milliseconds. All of what I've explained happens within seconds. So this is what actually happens each time you try to look for a website. Each time you go to a website, this is what actually happens in the background. So now we've said that this is the last guy. This is the guy that actually has the website. This is the guy that is keeping that website, this computer here, or we'll call them servers. This is the guy that is actually keeping that website. And now, what does AWS, in this case, we're looking at AWS as our cloud provider. What does AWS offer to be able to do this last stuff here? What does AWS offer to be able to do this? Now, that will bring us to our next topic, which is AWS Route 53. AWS Route 53. So this is the service that AWS offers to you as a user or a client to be able to route traffic, right? To be able to route traffic. And this is that service that is going to host the records, what you call your records. This is that service that is going to host the documents or the IP addresses. It's going to represent, it's going to be able to translate it. Now, earlier we spoke about DNS, right? This is it. We spoke about DNS. We said DNS is a domain name system which translates human-friendly host name into machine IP addresses. Now, if you look at the next line, it says www.google.com is equal to 172. Now, what I'm saying is this service, this is that service that is able to do this. This is that Route 53. Route 53 right here is the service that is going to be able to translate this human-friendly name into IP address. It's a service offered by AWS. So this is where we are going to create the, records. We call them records, right? So a record is basically binding a human-friendly domain name to an IP address. That's at a high level, that's what a record is. It binds a human-friendly domain name to an IP address. And we're going to create those records in Route 53. So you can look at Route 53 as the gateway between whatever a human being is typing out there and the actual resources that are in your cloud or like that are hosting the application. So these resources will normally or most often than not be virtual machines or EC2 instances in the case of AWS. These are the virtual machines or the servers. We spoke about cloud computing and we said that rather than having physical servers on-prem, you want to move to the cloud where you use virtual machines, right? So these resources I'm talking about, they are actually virtual machines and servers most often that are hosting your application. This is where the website is sitting. This is where the website is sitting, probably in a VM, in an S3 bucket in case of a static website. This is where they sit and they have an endpoint. For those that don't have endpoints, they have an IP address and you use Route 53 to create those records. Next, Route 53 routing policies. So like I was saying, this is the guy. When you think of Route 53, you think of that person that is able to help you as a human communicate with machines. Machines understand, it's like a translator, basically. So machines understand IP addresses most often. And us humans were used to names and we're used to names and words. So this is that translator between us and them. When we type in google.com, it knows that it's asking for a certain IP address and it's able to relay it. So being a middleman, right? Being a middleman or a translator, it has various ways of translating. Let me use that word. It has various ways of routing, right? You can see they are listed here. You have a simple routing. Simple routing is just where you put in a request and the Route 53 just it returns a simple value, which could be just one IP address. It has weighted. It has weighted. Now, weighted is a scenario where I would not really like to go deep into this, but today what we are going to look at mostly, we're going to look at two scenarios, right? We're going to look at geolocation. So out of all these routing policies, right, we're going to look at geolocation because if we want to go deep into all of them, we're going to take a lot of time. So when it comes to Route 53 today, we'll be focusing on geolocation, and I'll actually show you guys how it works. We're going to be looking at geolocation. So those are the various ways in which Route 53 can route traffic so as to deliver content based on how we define it. So as a cloud engineer, most often than not, you will be responsible for creating these environments where creating and managing these routing policies and stuff like that in this case or in this scenario. So when I was talking about geolocation, routing policies, geolocation, which is what we'll be focusing on when it comes to Route 53. Now, before beginning, I gave an example of where you're in Cameroon and there's this your favorite shopping website you use is in English, and then you happen to move to France and you want to access this website, you discover that it's in French, and you're wondering how is that done. Now that's a geolocation routing policy. That's what has been done at the back end. So we say this routing is based on your user's location. So Route 53 is able to determine the location of which that request is coming from and then deliver the pre-configured content that has been configured in the back end for that particular location. So it's based on the user's location. So we say we specify locations by continents, countries, or by states, right? So we can do that granular specifications. And here's a key point with geolocational routing policy. We should create a default record. We should create a default record in case there's no match. Now here's a very good scenario. If you have a website or an application that has most of its users from the US, most of its users are from the USA, right? Let's say you're in the USA and your application, most of your clients are from the USA, and you know that USA is an English-speaking country. But then you also have clients from France, and you have clients from Germany, but they are not as much as those from the USA. And then you know that besides the USA, there are other English-speaking countries. So what's the idea here? The idea here is that you would normally create a default record, right? Because your application is English native, is natively English. You might say, hey, anyone from the United States, right? Anyone from the United States, you create a record for the United States. You say anyone for the United States, route them to the English version of my application. You create another record that anyone from Germany, route them to the German version of my application. Anyone from France, route them to the French version of my application. Those are three different scenarios where you've mentioned three different countries. Now, the default record says that, all right, what if someone is not from any of these three countries? What if someone is not from the United States, the person is not from France, the person is not from Germany? What should I do? That's where you create a default record. And usually the default record is the normal or the default state of your application. So you can say that, hey, if anybody is not from these three countries, send the person to the English version, because by native we're English. So if anybody is not from these three, send it to the English version. So that's the default. There has to be a default because it makes sense, right? You cannot mention all countries in a particular record. So that's the idea behind using a default record. Okay. So diagrammatically, at a high level, this is what Route 53 geolocational routing looks like. You see someone from Washington, USA. The person hits Route 53. So when you look at the diagram of that person from Washington or USA, that's the person's browser. When you look at that Washington, USA, look at it like a browser, like how you go to your browser and you do stuff. So that's the person typing in something on his browser. When he does that, what that request does, it hits Route 53. And Route 53 sees the location of that request. And Route 53 says, hey, I have a record here that maps to a certain server, and that server is for USA clients. Route 53 is going to send it to the first one up for USA. And if someone from Sri Lanka is doing the same thing, it's going to send it to the resource that has Sri Lanka. So at a high level, that's how geolocation is. And we're going to be able to configure all this in minutes. Yeah, we can do that with clicks. Nothing really difficult. So another scenario with Route 53 is latency based, right? So we're not going to see this one today in practical because I really cannot demonstrate that right now. But latency based, the idea is that you want to configure Route 53 in such a way that it should route your clients to the closest resource to them. So as you can see here, it says redirect to the resource that has the least latency close to them. When we talk about latency, you should think about the time it takes. So if I take 5 minutes, right, to move 100 meters, and then person B takes 2 minutes to move 100 meters. Person B has a lower latency than me because it takes a lesser time and it's more efficient. So that's latency. When you think of latency, when you see latency, think of the time it takes. So for those to ping those responses, those resources and get responses. So what's happening here is that normally when you're architecting your infrastructure or on AWS cloud, for example, you want to do it with a lot of availability. You want that there should be some of your application in region A, and it should be resilient in another region, right? So you want to architect for high availability normally. So looking at the case where I made mention of you having clients from Germany, France, and all of that. So if we take that same scenario and we look at it in the sense of you having your application in a server that's hosted in Germany and you having your application in a server that's hosted in France. Now, what you're going to tell Route 53 is that, hey, if someone wants to access Solavise Tech, normally we know that Solavise Tech is based in the USA. That is where it is normally based by default. But because it is based in the USA, we also have branches in France and Germany. By branches, I don't mean physical locations, I mean servers, virtual servers in those two locations, which are hosting our application. So because we know that we have that high availability, we can tell Route 53 that, hey, if someone from Germany wants to get to Solavise Tech, rather than coming all the way to the United States, use what is in Germany to serve the person. Now, because Route 53 because you're using what is in Germany, that person is going to receive that information from Solavise Tech at a shorter time because the Solavise Tech he's actually receiving that information from something that is closer to him. So the latency or the time it takes is going to be lower. Same for the France scenario. Rather than coming all the way to me, it's just like the concept of edge locations, which was explained in the previous sessions, edge locations, where rather than the request coming right to the original server, it uses edge locations to serve that cached data, right? So it's the same as the concept of cache location, but the difference now is that these are not edge locations. These are actually your resources in those physical locations, and your clients from those locations can access it where it is, right? It's just like taking your application closer to customers rather than relying on a single point or main point where you are. So that's how latency works. Another scenario when it comes to routing policies or is failover. So it's a very interesting and I would say intelligent service, because now in this case, Route 63 is able to, so architecture-wise, these are your servers, right? These are your servers here. When I say your servers, you should think of it as the actual place where your application or your website is sitting. This is where your website is. So these are them. There are many of them. It cannot be one. It cannot be one. There are usually many of them. So these are them here. And each time Route 53 receives a request for that website, it is able to analyze all these servers having your website to check if they are alive, to check if they are healthy, to be able to respond. Right? You don't want to send requests to a sick server. So it is able to check them and really analyze if they are healthy and able to work. Now, if it checks a particular server and it notices that it is not healthy, you can now tell Route 63 that, hey, route my policies based on failover active passive. That is, you can tell it that once you check a server and it is not healthy, use this alternative one. So it checks, and if it is not healthy, it fails over to another one. So this, if you see this routing, this failover routing policy, it's some sort of an implementation of disaster recovery, right? Where you tell it, hey, if something is wrong with the initial one, fail over to a secondary one. Yeah. So that's at a high level, that's Route 53. So like I said initially, we're going to see, despite having going through failover, latency-based, and geolocation, I know there are other ones that I've not touched, but I just feel like these are the most simple ones that I can actually make you understand for now and actually get the concept. So we're going to see how geolocation works, right? So if you look on my screen now, at the back end, you don't need to bother. I've already configured the geolocation and all of that. But what I want to show you is how as you can see here, this is my Route 53. This is my Route 53 at a high level. As you can see, I am mapping this domain name here. To these various IP addresses. So you see, these are IP addresses, and these IP addresses are actually servers that have my website. So I have mapped this domain to these different IP addresses. And I have configured them for different locations, say default, France, Germany. So I've been able to do that at Route 53. Now, what we're going to do is we're going to try to access our website, sensini.blog.k. So at a high level, let me see how that works. So if I try to access this website, yeah. Okay. Let it load real quick. So I'm just going to wait for it to load up. For now, are there any questions? Does anyone have questions? I will take questions, if any. Hey guys, does anyone have questions regarding content delivery with AWS Route 53? Are there any questions?
Yes, Peter, you can unmute yourself.
You can, if you have a question, you can unmute yourself and ask.
Okay. All right. Thank you very much, Engineer Sensini. Thank you very much for this interesting presentation. My question is related to maybe cost when you are creating the different geolocations. when for like you said, is there an advantage, or when somebody has maybe creating a website and then has so many uh, geolocations? For example, like you said, maybe you are having a default in the US, and then you are creating with the other different in maybe Germany, Japan, China, and you have to do all that in all those places. Is there any advantage of having so many? And what about the cost? Is it different? I just want to know too about that one. Thank you.
Oh, okay. Yeah, you're welcome. It's a great question. So basically, when it comes to Route 53, there's the concept of hosted zones, right? So we create hosted zones. So, okay, besides even routing policies, Route 53 gives us the ability to purchase domains. So it serves as a domain registrar as well. So you can actually purchase your domain via Route 53 and you register the domain there. You all know that when purchasing a domain, you get to renew it every year. When it's expiring, you have to renew it, right? And that, I think that's about, depending on the top level domain, which is a .com, .org, or whatever, depending on that, the costs vary. And typically or averagely, your domain, to renew your domain would cost you like, let's say $10, $12 a year or so. And besides the concept of domains, we also create hosted zones in Route 53. And these hosted zones, AWS charges us for hosted zones a month, right? It's not actually a huge charge though. So if you look at it critically, I would say they are free, right? Relative to how other things cost on the AWS cloud. The charge is really small. Like for example, I have a hosted zone here and I get to pay $1 a month or so. It's $2 a month for that hosted zone. So when it comes to these different routing policies, you spoke about advantages and disadvantages of one over the other. These different routing policies are not there so as to make another one less important. They are there as a form of options, of use cases. What may work for you and what you may use Route 53 for you and your company may not be necessarily what another company needs it for. For example, if you're a company with a lot of restrictions as to where your content is served, you would normally want to look at look at the policy of geolocation to make sure that you're serving different kind of content to different people. But now another company that doesn't have that kind of rules, or they don't see a problem with that, with serving just one version of their application, they are probably not going to look at that. So these different policies are just there to give you a variety of options. And your question is also tilted towards, if someone creates geolocation for so many countries and another one creates for lesser countries, is there an advantage? No, there's nothing. If someone has created for so many countries because they need it or they want it, but if you create for less, it's because you have just less to serve different versions of your content to. So you should not be looking at these different policies from an advantage point of view, but from an option point of view to give you more options. Okay.
Okay, thank you very much. That means it depends on the need of the company.
Yeah.
Maybe
Yeah,
the need. Yeah.
Exactly.
Okay.
It depends on your need.
Okay. Then second, another question.
Yes.
Yes. Concerning latency. Thank you for that. I think I was able to understand when you are talking that it's based on the traffic between users and the AWS regions. And we gave the example of maybe the default of the server of maybe the region. You are giving the example of Solavise Tech, and you are saying it's in US, and maybe the content has to, maybe you need somebody to access that information in Germany. I really wanted to, and really to understand very well, is it that is he going to work with the AWS region in Germany? Is he going to take that option, or I didn't really get very well whether he's getting directly from the server from the US before the time is less, or is from the one in Germany. I didn't really get that. I really want you to clarify me on that again.
You're speaking of latency-based routing, correct?
Yes,
Just
yes.
latency. Now, latency is completely different from geolocation in the sense that latency is based on how distributed your resources are across the AWS global infrastructure. So if you've decided to create one of your website in the USA, and you've created another one in Germany, and you've created another one in France for high availability, that's what you've done. Now, think of it this way. If you have your application in 3 different places, USA, France, and Germany, for example, for high availability, and let's say one of the reasons why you've decided to place your applications like that is because you have a fair share of customers from France and a fair share of customers from Germany and a fair share of customers from USA, which make up the majority. So that's why you've decided to decentralize your applications across those 3 different places. Now, if you doesn't it make sense to configure your routing policy in a way that those from Germany will be served from the application of yours that is hosted in Germany, right? I mean, for them to get the response faster. If their request is to come from Germany all the way to the US and from Germany to Germany, which internet speed will be faster? The one from Germany, right? And same for France. So latency based is like you're routing it based on your resource closest to them. Now, if there's a neighboring country to Germany like Australia, right? There's Australia. Australia could be closer, or let me take Belgium. Belgium and Netherlands could be closer to Germany than France. Now you have your application in three places. 3. Germany, France, and USA. Now, you also have clients from places like Belgium and Netherlands where you don't have your application in. But then those people want to access your application and they want to access it fast. Now, you've looked and you see that Belgium and Netherlands, they are closer to Germany than they are closer to France and USA. So then it would make sense that Route 53, when someone from Belgium or Netherlands wants to access your website or your application, they should be served from your application that you have deployed in Germany because that's the closest to them. And that they will be able to get it faster than if they are to go to France or USA. That's latency based. It's based, Route 53 is going to decide where to send that client based on the latency or the time it's going to take for that client to get a response. But with geolocation, it doesn't care about the time it takes. It's location bound. You specify a country that it is from this year, you send it here. So that's geolocation. Okay. So like you will see here, I've configured geolocation for this native website. So let's just say this is my website, right? And in the back end, what I've done here, where is my Route 53? So this is my Route 53. This is my website, click here. So I've configured a geolocation routing policy and I've said that, look at my default. There's a server with this IP 54 and I've put it at default. What does my default mean? My default is the English version of my application. And we could look at default as the rest of the world. The rest of the world. And basically what I'm saying is that if someone is not from Germany, because if you look at the records here, I have France and Germany that I've specified. I have only France and Germany that I've specified. So basically what default is saying here is that if someone is not from Germany or France, send them to this English version, which is this. Send them to the English version. That's what Route 53 has done. Now, if I change my location, let me try to do that. Let me try to change my location a bit. in, let me pick Germany. Okay. Great. All right, guys. So unfortunately, I'm having problems connecting to a VPN right now. I would have really loved to connect to change my location and actually show you how. If I oh, are you getting now?
Yes, we're getting you.
Yeah. So I would have loved to really been able to change my location and actually show you how, if I switch to Germany or another location which I've configured, I will be able to let me send this. The VPN is actually disturbing my network. Each time I try to connect it, it turns me off. So I'm going to send this now. Yeah. So yeah, if anyone can change their locations to France or Germany, they will be able to access the German version or the French version of this website. But yeah, that's the default, which is English for the rest of the world. So next up, what we're going to look at next is we're going to look at CloudFront. So CloudFront is another service used by AWS for content delivery, right? This is another service used by AWS for content delivery. Most often, it works with Route 53. When we're architecting, we use them together for so many other reasons. So as you can see, CloudFront is part of it's a content delivery network. I believe a little bit about CloudFront has been spoken about in previous sessions. So what CloudFront does is it improves read performance. It improves read performance as the content is cached at the edge. So if you notice that sometimes where if you access a website for the first time, it takes about 5 seconds to load. It takes about 5 seconds to load. And then let's say 10 minutes after you try to access the same website and it takes 1 second. Why is that? That's simply because in the case of CloudFront, what happens is the very first time you try to access that website, that request goes all the way to the actual resource that is hosting that website, be it a VM or an S3 bucket. That resource goes all the way. So it takes longer for it to be delivered to you. Now, when it's delivered to you, CloudFront has these mechanisms that it's capable of storing your data at the edge. So CloudFront actually works with edge locations, right? It actually works with edge locations. So edge locations are just points of presence that AWS has. They are not data centers, yeah? They are not data centers or regions or availability zones. No, they are mainly used for content delivery, edge locations, to bring content closer to customers. So this is what is native to CloudFront that CloudFront actually uses. And it has this ability to tell the edge location for how long that data should be cached. Like what in the case of your browser, when you access a website for the first time and it takes 10 seconds, and the second time it takes 1 second or 2, it's because your browser has cached that data. Your browser kept it. That data you've received the second time, it was already loaded. And your browser was told that, hey, keep this stuff, keep it. And when it's telling your browser to keep it, it tells your browser for how long it should keep it. So it tells your browser, hey, keep this content for the next 1 hour. Or keep this content for the next 2 minutes. Now, there are advantages and downsides to this. For example, if you've configured your cache time to live for your application to be 5 hours, and then it happens that your application is that kind of application that you do frequent updates on it. You do a lot of updates. Let's just say it's a news, for example, news. Let's say BBC. For example, that's a news, their website is where people go there to get a lot of news and stuff like that. So imagine that they configure their cache data to live on people's browsers for 12 hours. That will mean that for each time someone puts a request to their website, what that person gets, no matter how many times that person accesses that website again, within a time of 12 hours, they are not going to get any new updates, of which there might have been new updates at the back end. So in effect, what I'm saying is, if BBC configures their website for a time to live of 12 hours and you go there now, you're going to get news and all of that. And in the next 2 hours, the news that you got has been updated. There's more information. If you go there again, you're not going to get the updated one until that 12 hours passes. So that's the idea between time to live. That's the concept. So now what this does is that it helps read performance because you are not constantly hitting the application or the database. You're not constantly hitting it. So it helps with low latency and high read performance, right? And also less pressure, or let me say less traffic or requests on your database or your application itself. It's less stress because at least it has some time to remain somehow idle or with less traffic. Now, if you put a lower time to live, that will mean that requests will be coming to your application more often. Yeah, so that's just the opposite of it. And that's how CloudFront works at a high level. Now, just like Route 53, which we talked about earlier, CloudFront has this capability of restricting people from accessing your content based on their location. So it has something, just like how Route 53 has geolocation routing policy, CloudFront has geo restriction. So we can actually, I remember at the beginning of this session, I quoted another example that if a friend of yours from the United States sends you a website to access and do some stuff, and you try to access it and you cannot get it for some reason, that's probably because that website has blacklisted or blocked your location from accessing it. So CloudFront has that ability to say, hey, if the request is from this location, don't give access to it. Don't give access to it. So that's CloudFront has that about it. And I actually intend to show you guys. I don't know why my VPN is misbehaving, because what I actually want to do is show you how the geo restriction works as well. Let me see what I have here. Oh, okay. So can you guys hear me? Please let me know.
Yes, yes, we get you.
Okay, so so this is the default or English version of my website, right? With Route 63, which we spoke earlier. This is the default or English version of it. So let me try one thing. Let me try to refresh it. Has anyone noticed anything? Has anyone noticed something?
The language has changed.
Yeah. So I just refreshed the website, and now I'm being served a French version. Just because the location of my PC has changed to France. And all of that is handled by this guy. That's just seamlessly. So if I do one thing, if I switch to Germany, where's Germany? Let me try and change my location to Germany. Okay. Okay, can you guys hear me?
Yes.
Okay, so let me try and refresh this. So do you still notice another change?
The language has changed again.
Yeah.
Now to English.
It's due, you know why it keeps changing to English, right? If you see, my browser is prompting me here to change the language to English. But let me put it on German. Yeah. So if you notice, now it displays me the German version or the Dutch version of this website. And that's because I have changed my location on my PC to Germany. So this is how it's done. Whenever you go on a website and you experience stuff like this, at least you know what's happening in the back end. It's just a simple configuration behind here. Yeah. And now, yeah, so thank God I was able to actually show you how the language changes. Now let's do, that was for Route 63. Now let me show you how CloudFront is able to block access to a specific website. So I'm going to do one thing. Yeah. So you see how simple it is, right? With just clicks, I'm able to create a record. Simple geolocation, failover, everything is there. Once you know what you're doing, they are not really as complicated to do as you would think. Okay, so if I come to CloudFront, so you see it's even here, geographic restrictions. So if you see here, this is what I was talking about. So I'm in the CloudFront console right now, and these are the features. So I spoke about geo restriction. This is it here. I spoke about geo restriction, and I say that you can restrict who can access your distribution or your website by an allow list. With an allow list, you allow your users to access your content only if they are in one of the countries. With a block list, you prevent your users from accessing your content if they are in one of the countries you've banned. So actually what happens, what they are trying to say here is that this is CloudFront, right? Under geo restrictions. I had a restriction here for block list. Now, I've mentioned France, Germany, and United States. And that is to say that if anyone is accessing this website from France, Germany, or United States, block it. Now, apart from using a block list, I could still use an allow list, which will now mean that if someone's country is not in the list that I'll specify here for allow, don't give them access. So there are just two different ways. So in this case, I decided to go with the block. So let me see what we have here. Yeah, this is it. So you see that currently the location of my PC is set to Germany. Currently it's set to Germany. But because I have configured my CloudFront to block all requests from Germany, I've configured my CloudFront to block all requests from Germany. When I try to access my website, it says the request could not be satisfied. The Amazon CloudFront distribution is configured to block access from your country. It has blocked it because I'm from Germany. And that would be the same if I switch to France. Let me actually kind of like show you. So yeah, I'm now in France or Paris. If I try to access my website once more, it says, hey, you've been blocked again. That's simply because in my block list, there's France. But now if I switch off my VPN, if I switch this off, if I switch this off, now this will mean that my IP address is going to change back to my normal local IP. And let me try to access the website once more. Oh, yeah. So I've switched it to my local IP, and now CloudFront has seen that my local IP is probably from somewhere in Africa and is not among these countries. So it has given me access to the website. So it has given me access to the website this time. So that's it around content delivery at a high level. We've touched the two main services, AWS Route 53 and CloudFront. We've seen how Route 53 is able to send users to different versions of our application based on their location. And we've seen how with CloudFront, we can block access to certain people, to our application from certain people. And that's the end of this session. Thank you very much. I hope you've had a great time, and I'm available for any questions. Do we have any questions available? You can let me know.
Guys,
Okay.
can we show some love to Prof. Sensini in the chat? Thank you so much. Thank you so much for this practical session. Thank you so much. It has been a hands-on session, guys. You guys have seen practically how you can use Amazon Web Services. All right? You've seen practically how you can use Amazon Web Services. Are there any questions? Yes, Peter, your hand is up.
Yeah, thank you very much, Prof. I think it was really very interesting. I have a question just for what you just did, the last thing you just did was very interesting to me with the VPN. So it means it's like I using VPN, or I can easily switch even with my laptop where I'm working to show that I'm working in a different country, or I'm really amazed by that. It's something that's interesting to me. I just want to know.
Yes. So a VPN is a virtual private network, right? And and this is just the basic around everything you will be doing when it comes to cloud computing. Well, what we're all talking about a private network. So it's you can use a VPN to change the IP address of your location. Yeah, to change your location. But there are websites and there are softwares that are strong enough to determine if you're using a VPN or not. Yeah, so, and there are also VPNs that are strong enough to bypass that detection. So it's, yeah, you can use a VPN at a high level. You can use a VPN to change the location of your phone, your laptop, whatever you're accessing the internet with. You can do that. That's what I did. Right? Yeah.
Yeah, thank you so much. I observed it. Thank you so much. Thank you.
Oh, you're welcome. Thank you, everyone in the chat. Like I said, any questions you have, no matter how dumb you think it is, just throw it. You can unmute yourself, and if you have anything to say, go straight away and say it. No worries. Okay. That being said, I think Doc, you have the session.
All right, thank you so much. Okay, this is one of the beauties of working from home. Hey, calm down. I have my little man here all the time when I'm training, when I'm at work, when I'm in class. He's always here, guys. That's amazing. Okay, calm down. All right. So, all what you guys have seen here is just the tip of an iceberg, right? Like, we're going to go deeper into CloudFront. The objective of this session is just for you to have an idea of what you're going to be seeing as from the month of October, right? We're starting off October 7. We're going to take you guys step by step on how you can be able to also host websites, because what Prof. Sensini has just done now is a mini project. We're going to teach you guys how to build that project. It is using these projects now that you'll be able to document. When you document these projects, you can either document and save in something we call GitHub, right? You can actually write down all the steps on what you did so that other people can be able to use what you've done. Or you can equally record it, right, and maybe save it on, say, a YouTube channel, all of that. And now you can also document this in your resume. And during interviews, during job interviews, you can walk the interviewer through how you were able to build the solution, because there are companies that will need these solutions, but then they don't know how to do it. So they need an expert like you, right? They need an architect like you to come and help them design such a solution. And also, when you help them design such a solution, in other cases, we have people that are more interested in building things, right? So those are now the engineers who will now go in and implement that architecture. So just like some of you were asking the question around, okay, which is maybe why would maybe geolocation the advantage over the other? So the architects will go ahead first to gather the client's need. What is the requirement of this company? We're going to have a conversation first before they even make it to the cloud. And then we're going to describe to them the advantage of cloud computing, right? Why they need to use cloud computing and how you can solve their problem. Peter equally asked a question around the cost. How can you save cost? So there are various solutions in cloud computing that we can use to help companies save cost. And as we move ahead, we're going to be teaching you guys one step at a time on how you can save cost, right? Now, the last training, which is going to be the 12th, I'm going to take in that class on storage. I'm going to show you guys how we are all going to host Solavise website using AWS. So the image which Prof. Sensini showed you guys, right, is the image of the AWS account. So each and every one of you will have your own unique accounts, which you will use it as your sandbox. You will use it as your playground. You will build solutions there and break them. You will build and break. We will teach you all along the way how to do that. So the last day, we're going to build our own website. We've written the code and everything. We're going to use it now, deployed on AWS, and you will see how that website is going to come up live. So unlike maybe trying to bother a lot on how can you be able to host a website, that AWS gives you solutions on that. And we're going to show you on the 12th how that is possible. So guys, thank you guys so much for showing up. We are right in time. And I believe you've learned something really great. And just like we did for the previous sessions, if you learn something, just kindly write down one thing you learned. Write down one thing you learned and you drop in the WhatsApp group. That's just to spread every other person, hey, there was something interesting, something amazing that was shared, you know. For those who didn't attend, you probably want to run back to the recordings. And just to let you guys know that the live sessions themselves in October will be done as from 12 a.m. For those who are in Africa, right? 12 a.m. Cameroon time right now, it's about 10:17 p.m., right? So 12 a.m. Why? Because at that time, network is more stable. If we notice, we chose this time because we're going to have a less, you know, a shorter time to interact. But then at 12 a.m., the network is much more stable. For those who are out of Africa, maybe say the US, 7 p.m. Eastern time is the time that, you know, everybody's back from work and all of that. So you're able to focus and study. So our internet connectivity is going to be much more stable by then. All right. So just to let you guys know as well, as we move on, for those who are already making steps towards attending the live session, you want to ensure that you have your computers ready, you have, you know, everything that you need. And most importantly, guys, I want to say this: the most important thing you need to go through this journey is focus. It's an open mindset. Many of us came into this, we never even knew how to hold a mouse and to work with a mouse and all of that. Many people had no IT background, but then as we're able to communicate this information with you right now, that's the same way you'll be able to communicate, and even better in 6 to 7 months' time. If you decide to have that open mindset, if you decide to commit to the process, if you decide to learn, right? Anybody can learn anything. So guys, that's what we have for today. And God willing, we're going to see you for the next session, which is going to be on the 10th, right? So at this time, if there are no other questions, you can, or maybe you have a feedback, any feedback or any questions, guys, you can indicate right now. All right, equally drop your reactions. Thank you for the reactions. thank you. Drop them in the WhatsApp group as well. Just drop them in the WhatsApp group. So any questions or reactions are welcome as we wrap up with the session for today. And God willing, we're going to meet again on the 10th. Any questions and reactions? If not, you can unmute yourselves and wish everyone a good night.
Thank you so much, Dr. Tux. Thank you so much, Prof. Good night.
Thank you as well, Prof. Eric, for being there today.
Okay, Prof. Thank you, Prof. Thank you, Prof. Sensei. That was really amazing. Like, you were on fire today, honestly. Guys, that's the spirit. By the end of the 6 months, everybody's going to be on the same fire.
Next class, we're going to have Prof. Eric, okay? So you can anticipate the topic we're going to have next class. Go ahead, take a look at it, and see you all on the 10th. Ciao.
Good night, team.